Hello and welcome to our video on the science behind earthquakes. Earthquakes are a powerful natural phenomenon that have captivated human interest for centuries. They are the result of the Earth's shifting tectonic plates and can occur anywhere on the planet, sometimes without warning. The sheer force of an earthquake can cause catastrophic damage to buildings, bridges, and infrastructure, leading to loss of life and property damage on an unimaginable scale. Despite the devastation they can cause, earthquakes have also been a subject of intense scientific research and study. Understanding the science behind earthquakes is not only fascinating, but it's also vital for preparing for and mitigating the effects of these natural disasters. In this video, we'll explore the mechanics of earthquakes, the history of earthquake research, and the ways in which people can stay safe and protect their communities in the event of an earthquake. So, let's dive into the fascinating world of seismic activity and discover the science behind earthquakes. The internal structure of the Earth is divided into three main layers: the crust, the mantle, and the core. Each layer is defined by its composition, density, and physical properties. The crust is the outermost layer of the Earth and has an average thickness of about 30 kilometers. The crust is composed of two types: oceanic crust and continental crust. The oceanic crust is thinner and denser than the continental crust. The mantle is the middle layer of the Earth and extends from the bottom of the crust to a depth of about 2,890 kilometers. The mantle is divided into two parts: the upper mantle and the lower mantle. The upper mantle is composed of solid rock, but the lower mantle is thought to be partially molten. The mantle is the thickest layer of the Earth, accounting for about 84% of the Earth's total volume. The core is the innermost layer of the Earth and is composed of two parts: the outer core and the inner core. The outer core is a liquid layer of molten iron and nickel, while the inner core is a solid layer of iron and nickel. The core is the densest layer of the Earth and accounts for about 15% of the Earth's total volume. The internal structure of the Earth is considered to be responsible for many of the Earth's physical properties, including the plate tectonics and earthquake activity. The Earth's crust is divided into several large tectonic plates. These plates are in constant motion, moving around on the Earth's surface at a rate of a few centimeters per year. The movement of these plates is driven by the convection currents within the mantle. The mantle is made up of hot, molten rock that circulates in a pattern similar to that of a lava lamp, and this convection process creates a swirling motion within the mantle that causes the tectonic plates to move. The heat that drives these convection currents is generated by the Earth's core. The core is incredibly hot, with temperatures estimated to be around 5,500 degrees Celsius (9,932 Fahrenheit). There are a few different types of plate movements that can occur. The plates can collide and one can be forced down below the other in a process called subduction. This can cause immense pressure to build up, which is eventually released in the form of an earthquake. The subduction process can cause massive earthquakes that can wreak havoc on communities living near the affected areas. The 2004 Indian Ocean earthquake was caused by a subduction event that occurred off the west coast of Sumatra, Indonesia. This earthquake had a magnitude of 9.1, making it one of the most powerful earthquakes ever recorded. It triggered a series of devastating tsunamis that affected several countries in the Indian Ocean region, resulting in the loss of over 200,000 lives. Another significant subduction earthquake was the 2011 Tohoku earthquake in Japan. It occurred when the Pacific Plate subducted beneath the Okhotsk Plate, triggering a massive 9.0 magnitude earthquake. The earthquake led to a series of tsunami waves that caused widespread destruction along the northeastern coast of Japan, claiming more than 15,000 lives and causing extensive damage to infrastructure. Another type of movement is when two plates slide past each other, such as along the San Andreas Fault in California. This type of movement can also result in large earthquakes. The location where an earthquake occurs is called the epicenter. The epicenter is usually located along the fault line between two tectonic plates. When an earthquake occurs, the waves of energy that are released travel through the Earth's crust and can be detected by seismographs. Scientists use these waves to measure the intensity of the earthquake on the Richter scale, which ranges from 1 to 10. The higher the number, the more severe the earthquake. Earthquakes can strike at any time, and being prepared can make all the difference in staying safe and protecting your community. Here are some practical tips to help you stay safe during an earthquake. First, prepare an emergency kit with essentials such as food, water, first aid supplies, and important documents. Keep it in an accessible location. Second, identify safe spots in your home or workplace where you can take shelter during an earthquake. Third, secure heavy objects to prevent them from toppling over. Fourth, stay informed about earthquake warnings and alerts in your area. Fifth, check on your neighbors and community members, especially those who may need assistance during an emergency. Lastly, if authorities issue evacuation orders, follow them promptly and without delay. Remember, earthquakes can be unpredictable, so it's essential to be prepared and stay vigilant. By following these practical tips, you can stay safe and protect your community during an earthquake. Thank you for watching and learning about the causes of earthquakes. Despite the devastation they can cause, earthquakes have been extensively researched by seismologists and other scientists. Through their efforts, we have made significant progress in understanding the mechanics of earthquakes and developing tools to predict when and where they will occur. As a result, we now have earthquake-resistant building codes and early warning systems that can save lives. If you found this video informative, please consider liking and subscribing to our channel to stay updated on future content. We appreciate your support. And for those of you who have made it to the end of the video, please leave a comment with the word Tremor to let us know you're one of our dedicated viewers.